Hello everyone. Spotify is a very popular music service. Spotify does give the developer access. It means using the Spotify API as a developer, you can make request to the Spotify server and you can get your desired result, such as you can search for tracks, you can search for artists, you can search for the song features, you can search for artist popularity, the different features available in the artist songs, the top songs from a given artist. So various things you could collect by using Spotify API. So if you are a Python developer or a data scientist or you love to work with data, this tutorial is going to be very helpful for you. So hello again, my name is Avkash, and in this tutorial, I will be giving you a step-by-step guidance to use the Spotify APIs and build an application using Python to extract the information from Spotify APIs, such as artist information, their song, top songs, the features in those songs, just search various songs similar to a given songs, and create a data analytics application within the information which we are going to receive from Spotify API. This tutorial is divided into two parts. In first part, we are going to use just Python and Spotify API to collect all that information and build an EDA kind of application where we are just analyzing the song details, popularity, audio features, and see which song is better than other, etc. But in the second part of this tutorial, we are going to take all the Python work we have done in this tutorial and convert it into a Streamlit application, where one single application has the interactive UI. So one single application which is fluid, has graphs built into, has analysis built into, and that will be part of our second tutorial. I really enjoy creating these tutorials for you guys, so please enjoy. So let's get started. If you would want to build any application using the Spotify music service, your first step will be to create an account with Spotify.com. Once you will have an account with the Spotify.com, the next step for you is to set up your developer account, which you are going to use the developer.spotify.com, and using your same credentials, you can start using the Spotify for Developer service. After that, you will have an opportunity to create the applications related with Spotify service. And these applications could be anything where you are going to use the Spotify APIs to connect to the Spotify service and process whatever data you would want to use with. Here, I have created the Spotify Streamlit demo. Here is my application initialized at the Spotify developer account. And here is my client ID, and here will be my secret. In this tutorials, I will be using this client ID and client secret, but after the demo, I will reset this secret, so it will not work for you. So whenever you are going to use the demos, which I will be showing you in this tutorial, you would be using your own client ID and your own client secret. So this is minimum requirement you have to have in order to follow this tutorial as well as try by yourself. So after you have a Spotify developer account and your Spotify application is created for whatever your objective or purpose will be, you must need a client ID and the secret. In this tutorial, we are going to use this Spotify Python library. I will suggest you to spend some time study the documentation so you could learn how you could use Spotify Python library in your Python application beyond this tutorial. So this documentation is really very useful for anybody who would want to use the Spotify services using Python programming language. Before we start this tutorial, it would be good that I could shout out some of the resources I have gone through to learn, and I will be using some of the code from these open source GitHub projects people have created in my demo too. So I would like to give the credit for all these great developers for providing some of the information was needed for me to complete my tutorial. So here we also have a tutorial from here, and this article was really very helpful for me when I was building this tutorial. The Jupyter notebooks which are used in this tutorial, they can be found in this Spotify projects folder, and this public repo is available at the GitHub, and this public repo name is public code, where all of my tutorials are available. So please clone this repo and get these Jupyter notebooks which we have covered during the various exercise in this tutorial. Jupyter server running locally in my machine, and all these Jupyter notebooks which we are going to cover in this tutorial, they are all running at my local machine. Very first, we will look into the installation of Spotify. As you could see, that Spotify is already installed in my machine, so we don't really need to install. And the Python version which I am using in this tutorial is 3.8.12. So that runtime version is going to be used in all of my Jupyter notebooks. So now we can get ourselves started with the Spotify library uses to connect with Spotify music service and start accessing the various features. So you already know that Spotify is the music service. It means it's going to have the artists are going to create these songs, which we call them tracks, and these tracks will be packaged into the albums, and a particular artist is going to create various albums, and these albums will release in different segment of time. So that's all going to be the feature set for us to use with Spotify services. And we are going to have multiple Jupyter notebooks to learn various things from start to finish in each Jupyter notebook. So first, we need to import the Spotify, and we also need to import the Spotify client credentials, because these credentials methods will be used to pass your client ID and client secret so that you can start using Spotify object to connect with Spotify backend service. Here I have already written my client ID and client secret. You must be using yours, because if you are going to use this demo, the secret will not work here. The other alternative is that you can pass these two variable, client ID and client secret, through your environment variable and read from there. So here with this Spotify client credentials method, I'm passing my client ID and client secret. However, if you have these two values in your environment variable, you may not need to pass it here. So I do have a Spotify object available as a SP. It means that this object will be used subsequently wherever I will be connecting with a Spotify service. So first we need to search albums. Albums could be any string name, that's where, and here I have this word called shape. So I will be searching using the search method which is available on the Spotify object, which we have got after we have connected to Spotify service through our correct client ID and client secret. Here we have made a call. Request went from my local machine to the Spotify server, and the result with all the album names start with shape has been given to us. As you could see here, the return albums is a JSON object. We can look into the length. Here you can see that there is 7 fields in the albums object. However, the items is the object where the list of our search result is stored. It means that when we made this API, we requested this API to return the 20 maximum results. If you will not pass this limit, by default, you are going to get only 10 results. So most of the APIs with Spotify, they give you default 10 results if you will not specify. And if you would want to see the information about the very first album out of these 20, this is what the information really look like. So here you could see that album type is album. Here is the artist ID, Foo Fighters, and where this album is available. So these are the markets where this album is available. Then you can look into the where the album URL is and album ID. Previously you saw the artist ID, and here is the color and the shape and when it was released. It has 14 tracks, so you got an idea. So if we want to get information about all the 20 records we have in this object, we need to iterate through. So here we are storing all the albums into this album list, and then we are iterating the album list to get the album name, artist, who's the artist is, what is the track ID, and what is the artist ID. And the information look like that. So by Foo Fighters, as I lay dying, and these are different artists and their albums. Here, if we choose any of these artist ID, so these are the artist ID and this is the album ID. So this is the album ID. So we have searched the album. So that's our album ID. Within this return object, we have artist ID. So if we could select one artist ID and we can place here. And after that, if we want to see that for this artist, what other albums this artist has produced, here you could get very quickly the list of albums produced by this artist. If you look into very first one, Foo Fighters, you take their ID, and here all those albums from Foo Fighters. So here we have artist ID, and I have selected the artist Foo Fighter, so that's his Spotify ID, and by using this artist ID, I will be making the list of albums produced by artist Foo Fighter, and here you could see that the list of different albums created or produced by Foo Fighter are available. If here is the artist, as I lay dying, I will select this ID, and here are these. Just make it comment. In the next step, we are going to search the track. So first we searched the albums, then we are going to search the track. So here we are using the keyword, and search requires the query track colon and type. So query is made and result is stored. If we would want to see our result, it will be similar to previous, like a JSON object which has all these tracks, and if we look into the length of result, it basically bunch of information comes, but here we have tracks. If you use the track baby, and let's try to expand that, the length of here is our 10 songs. So similar to the search where we got the 7 items, so that's just a package, the JSON package which is written by Spotify, which has a similar structure. So always the return will be your type, the type you are making request, and then after that the items, so which is similar to here. If you remember, you are making a request album and the album of items of albums. So that's kind of hierarchy you're always going to follow. So here we have the 10 songs based on baby. If you want to get larger, you can say you want 20 result, and let's here, now you see we have a 20 songs here. So depending on what your requirements are, you can control the number of songs you want based on a given search. So our objective was shape of you, and now we have 20 songs based on shape of you. Now again, the tracks and items has all the items in the track. So we are going to iterate, and here we are going to get the top 20 songs or first 20 songs we found in our search. So here is the song by, what's the track ID, and who's the artist ID. So here we have a track ID, artist ID, album ID. So you need to make sure that you are using the correct ID depending on what kind of request you are making or what you are processing in your JSON result. So these IDs, URIs, and URLs are very important for you to have an idea about it. So we have IDs, URIs, and URLs. So Spotify URI, Spotify URL, and Spotify ID. So here you could see Spotify track the given ID. So it will be Spotify track with this ID. If you say Spotify album ID, then it's gonna be album ID. And if you are using the Spotify URL, then it will be open.spotify.com, and then the type, which is the track or album, and its ID. So it could be track, album, application, playlist, or other resources. And finally, the ID is a base 64 number, which is like that. So all those IDs, no matter it's a track, album, playlist, artist, anything, they're all going to be base 64 numbers. So we have seen how you could make search for the albums or the songs. Now we are going to dig about the audio features. So audio features are documented here in this developer documentation. So whenever you are going to make the call to the Spotify to get the audio feature results, you are going to get these audio features in one track. So the JSON result from the API is going to give you these values. So you are going to get acousticness, danceability, energy, instrumentalness, loudness, speechiness, tempo, valence. These are the key features and some of the other JSON values. So when we are going to make a call, we are going to get same result. So here is the song. So we need to pass the song ID. Here we had all these songs we have found when we made the song or the track search. So let's use the very first one. This is the track ID. So initially I have selected the artist ID. So I need to select the track ID, and that's the reason our return for the track was none. So now we are using this song or track ID, and here is our track features. So as explained here in this documentation, we are getting these features. So for this song, here are the features: danceability, energy, loudness, speechiness, acousticness, instrumentalness, liveness, valence, tempo, and other URL. So this song is about that many milliseconds, so about 233 seconds, And I think that's the URI if you would want to access it. So this is a URI and this is the URL. So this object track features has all of these values. So now what we are going to do is that we are going to take this JSON object and convert it into a pandas data frame. So here we are taking this track features object and convert it into data frame features. So here is the features list which we have taken from this JSON object. Now we are going to create this polar graph, and the polar graph will be created to render the 1, 2, 3, 4, 5, 6, these 7 audio features for this given audio track. So here is the function and I will explain you, and here we are going to plot the polar graph. And we have 7 features, so 1, 2, 3, 4, 5, 6 and 7. So the instrumentalness is 0 for this one, so that's why you are seeing this instrumentalness is 0, and then rest of the values, they are rendered on 0 to 1 scale. So the values which we had here, they are rendered on 0 to 1 scale. So like Liveness is almost 0.09, so that's here. So just looking into this polar chart, you could get an idea how this song really look like. Now we can look into how this polar chart is created. So it's using the matplotlib library. As you see here, the features is basically this data frame, which is this is being passed into. So all those labels are collected. So these are the labels, and all the features which are available here, their means are added into this states object, and that list, all the means are into a list. After that, the angles are created by the total number of labels we have. So we have 7 labels, so that many angles values are created. So that's why you see that 7, 1, 2, 3, 5, 6, 7. So we have taken the 360 degree and split into that many labels. Then stats and angles, based on stats and angles are used. So concatenation happen for labels and angles. And after that, once we have got these states and angles value, now the next option is just to inject those values so that we could plot them. And then bottom here is just the label position and the y-text and limitation. So 0 to 1. So y limit. So this is how you are going to create the polar plot to show the audio features. And I have taken this code from one of the GitHub project as it is. So what I have done in this next step, that the whole code where you are going to get the audio features, I have converted it into a method. So get features, and where you just need to pass the track ID and it returns you the features. And it say if you get this error, connection aborted, it means that your client connection has been broken. It means you need to reinstate this connection back. So we have reinstated this connection back. Now we can come back here and we can make this call. df2, so here is the song, and that's the data frame for that. So for example, if we want to use another song, so there is a shape of you, acoustic. Let's use this track ID. And here is the new data frame related with the different song features. And here is the previous one. So if you would want to see the difference, you can get an idea. Because this is the acoustic song. So Speechiness value, you could see the changes. The valence is almost same. The energy is more in this one, is similar, and here is also acousticness is just almost 0.2 higher, so 20% higher. Here, as you could see, that these are the features going to be applied and compared. So now we have another method, feature plot 2, and it takes 2 audio features data frame and it creates the polar plot. So explanations are almost identical. And here you could see that we are creating the polar plot by comparing the two different songs. So you could see that there is not too much difference between here, but there is some difference in acousticness because this song has the acousticness and it also has more energy. So the previous song R magenta and R, if you want to make it blue. So here in this Jupyter notebook, we have covered three different objectives. We searched tracks, albums. We also accessed the artist and the total number of albums created by the artist. And we also accessed the audio features and compare them depending on our need. Now we will use the another example where we are going to use the song recommendation as provided by the Spotify API. So we are not using the machine learning by ourselves, rather than we are using the song recommendation API by Spotify, and we are going to get the similar or songs depending on our requirement. So some of the code is going to be the same here. So that's just initial code to get the Spotify object ready for us. Then we are searching song. So until here, everything we have already looked into. So these are the songs we have searched. So now depending on a song you choose. So for example, we have choose this song, Shape of You. So here is the song ID. Now we are going to get the recommendation. So when we are going to make this recommendation, we are going to make this call, which is making api.spotify.com recommendations. So here this is the recommendation API, and this API needs the token, and the token is generated based on client ID and client secret. So first we are using this requests and base64 packages to generate the token. So now we have got the token here. Here you could get the token. Now this token is going to be used to get the recommendations. So here is the song ID. So here you could see that we are going to see the track ID, so which we are passing here and then passing the token. So this is our recommendation for the given song JSON response, and here is the JSON response which came back when we made this API call. Here we are going to get the song name, artist name. So these are the recommendation we got when we requested the song similarity for the Shape of You by Ed Sheeran. Shape of You, if we call it baby, different search. Now these are the baby. So let's use this track song. So this is the ID. We don't need to create token again. We can reuse the token. And here is the making request. JSON response, and let's get the result. So here you could see that when we changed our song ID, now we are getting a different result coming out from different artists. If we look into the track little more deeper, we could see here that it actually shows various results related with song. It shows the what is the song, album, and the total number of artists belong to that particular song. So these are the similar song based on our request. So now we are creating the list of recommendations. So all the tracks are stored and the 10 results are available for us. If you want to see what is available in one of the recommendation, here you will get the recommendation details, when this song was released last year, popularity is 67. Now we are going to take this recommendation list which we have got from here and convert it into a pandas data frame. So now this is a pandas data frame, and as you could see here there is a list of all the fields we have available in this one. So it has the total number of 10 records. Now we are going to take some of these fields, name, whether this song is explicit or not, how long this song is, and what is this song's popularity. And we are creating a very small, like a subset of the data frame. So here is our subset of the data frame. Here is the song name, explicit or not. Here you could see that these three songs are explicit, and duration of this song and the popularity. Some of these songs are 90. Some of these songs lower up to 56. So min and max in popularity. So these are the just pandas data frame. So we could get the describe method. So these are the numerical fields, and our explicit is Boolean. So it has whether this song is explicit lyrics or not. And here is the true and false. So in the next step, we are going to create the scatter plot, where you could see that these are the names is on x-axis, and the duration in millisecond is on y-axis, and the S, which is the scatter plot, and the popularity is in bubble. But this looks really very dirty, and because it's not clear, so next we are going to clean it up and make it much more better and useful representation of graph. So because the duration is millisecond, so we could convert in minute, 1, and then popularity, because popularity is between 56 to 90, so we could actually subtract the minimum, so we will get the popularity from 0 to all the way to max. So here was our graph. So we have added these two features more, duration in minute and popularity range. Now we can look into our recommendation data frame. So you could see the duration in minute is here, and here is the popularities from 0 all the way to 29. So we have some better clarity here. Now we are going to build the same graph, but we are going to add some of the more design in it, so it will be more clear. So here we took this graph and modify it to look like little more better. So here very quickly we could see the sizes of the scatter plot. So we could understand that which song has popularity bigger than others. The color also proved that which song has the explicit lyric versus which song is not. So we can take a look here. So this is a wider plot. Here we are using x-axis is the song name, and we have made them 90 degrees straight, so at least we could see which song it is. At the y-axis we have duration of these songs, and then those plots, these bubbles, they are using the popularity range times 50. So it means it's bigger, because if we will not have this 50, these dots are really very small. So we are trying to make them little more bigger. So I think if we do 20, you can get an idea that okay. And here you will also see one problem is that this song has a 0 popularity, because it's a min minus min and it became 0. So to make it much better, what we need to do is that we need to actually use the recommendation data frame and actually just have the not the min, just min minus 1. So we will have at least this value, not 0, it will be 1. So here is the popularity. We add here, so popularity range, popularity, and we need to call it minus 1. So this value became 1 to 30 is max. So that was just a. Now let's rebuild the graph. Now you get the minimum popular song to maximum popular song. So you have clear differentiation. And rest of the graph is much more clear. It helps us to understand more. So this was our second tutorial where we use the Spotify API to get the recommendation or the similarity for a given song, and we have understood that depending on similarity what else we could get. But remember, if we could add the audio features along with these, we could actually build a better representation of the similarity. So combining audio features and The recommendation results will also help us understand that how close a song can be. Next exercise, we are going to compare the audio features between two or more songs. So here is our notebook. First few lines of code is common. We have already saw it earlier. In this next step, we are going to search a particular song based on keyword shape. And here is the data related with all the tracks with the shape word in them. And here we are just looking into the JSON response and creating this array called track result. So as you could see here, the track result is just a simplified version of the JSON response we have got from the search API. And previously we have dumped the whole JSON object into the pandas data frame. But here we just selected some of the values which we are interested into comparing. So here we have the album track ID, the track name, the popularity value, and the release date. So we have that available for us. So popularity is 82, release date, song name, and the ID. Next, we are taking this track result value and adding these columns to it and creating a pandas data frame. Now we have a data frame for the 20 songs we have received from this request. And if you see here, this limit is 20. For that reason, we have received the 20 songs. And this is our curated Python pandas data frame for our particular need. Now, what we are going to do is that we are going to iterate for each song ID, and we are going to make this request to get the audio features, and all those features related with this data frame will be stored in this local features, and then we are going to create this new data frame called features data frame, and we are going to take a look what we have received. So for every song ID, we received these danceability, energy, and all these audio features as we have already seen earlier. So now we have two data frame. One is our song data frame. Second is the audio features data frame related with selected song. Now we are merging these two data frame, left on ID and right on ID. So both data frame have the common column name ID. So we are merging it. Now we have a final data frame, which is a combination of all the songs ID, their popularity, as well as the audio features. So one data frame consists of all 20 songs, audio features, plus popularity, release date, etc. Now we are sorting it based on popularity. So this sorted frame is basically, here is our sorted frame. If you look into the popularity, 89 all the way to the 34. At this point, our objective is to plot the song related popularity plus a feature comparison. So here we will select a feature tempo, and we have a data frame which we have curated only for the plotting purposes. So here we have artist, album name, song name, when it was released, the popularity, and the feature name. So the popularity and the tempo. Here is frame look like popularity and tempo, and using matplotlib libraries we are going to create this plot. So as you could see here, for these songs, here is the let me see what is on y-axis is the feature name, which is the tempo. So here is the tempo, and the depending on size, you could understand some of these songs are very low tempo, only few songs are very high tempo. And if we look into the popularity, we have times the popularity, so we could get little more granularity built into. So you could see that some of these are so high tempo, and it's also popular, and the song is heart shape pop. So that's one way you could compare these features and you could build the better visualization depending on what your needs are. So for example, if we try to select another, maybe liveness as a feature and use here as a liveness. So we have new data frame, and here is, so here it also, the song colors and shapes is terms of liveliness, it's really very high. Rest of the songs are here. This song is the lowest one. If we try to multiply the popularity by 40, you have little more clarity to see which one is big, which one is small, maybe 30. So this was another exercise we just gone through to compare the audio features with one or more songs. In this next tutorial, we are going to get these top songs belongs to a particular artist, and we are also going to play the 30-second sample which Spotify API also gives when we try to make request for the artist top songs. So that's our exercise number 4. So first 3 lines are already we have seen multiple times. Next, we're gonna be selecting the artist name is Led Zeppelin, and based on artist Led Zeppelin, we are going to make the request artist name. So we searched the artist based on Led Zeppelin, and if you see here, we have received these records. Let's see, these are the artists, and here we have in the light of Led Zeppelin 1, and there is another one, Led Zeppelin. Yeah. So I think looks like these records we have. So first one is the real Led Zeppelin. Popularity is 80. The genre, album, rock, classic rock, hard rock, rock. And within the artist, you can also get some of this information like the followers, genres. So if you would want to build more visualization related with that, you could combine these information with followers, etc., with the popularity, and then build even better visualization for your project. So now we are going to create the artist URI, and here you could see that artist URI we have received from this URI. So artist item and then URI. So we have got the artist URI. So if we want to collect the artist top tracks, we just need the artist URI. So this is the artist URI, and making the call, we are going to get these top songs related with Led Zeppelin. If we want to change Led Zeppelin to, we want to say, for example, Justin Bieber. Here is the artist. We can look into. Here is Canadian pop, followers, Justin Bieber. Popularity 96. Here is another one, Justin by Brown. So here's the first one, who's the real Justin Bieber. Here's the URI, and if you would want to get the top tracks for Justin Bieber, here you go. So what is that? Because we are going to get the preview URL. So it looks like that for a certain track, there is no preview URL. So we just need to make sure that we make a check. If the preview URL is there, then we try to add it. Otherwise, we should not add the preview URL. Because in this tutorial, our objective is to play the preview song, which is available for us. So here is the URL which we have received. So let me change it very quickly. So if track preview URL is not none, add that. So here you could see that we have fixed the code. So now some of the songs, they do not have the preview URL, but if there is audio, we could play it. So here, depending on a song, you can get a preview URL. So Stay, Ghost, Baby, these are the songs. I don't care. So if you would want to have the any preview URL, you can get. So for example, we are going to take the first 0 index. So here is the preview URL. So if you would want to play, there is IPython, you can import the audio method and you can pass the URL and just add the .mp3 next to it. So at the very last, here is the song. Autoplay is false, embed is true, and we can play. That's a 30-second. If we would want to get the very last one, then we need to check this is a total 10. So we need to go the number 9 and we can play here. So you get an idea that how you could use the artist top songs API to get these songs along with their 30-second preview, and you can play them all at Jupyter Notebook. So that was our exercise number 4. Next, we are going to look at another exercise where we are going to compare the feature from the artist songs based on the top results. So we are extending the exercise we have done in notebook number 4 and do the feature comparison. So first 3 lines are okay. Now we have our SP object, Spotify API are accessible to us. Here we are selecting the Led Zeppelin this time. Let's use the Led Zeppelin. Here songs, and here are the lists of Led Zeppelin songs available. So this up to here we have already seen in previous Jupyter Notebook. Now here are the tracks. So all the top songs related with Led Zeppelin search is available for us in this results object. Now we are looking into the tracks, so result tracks, and as you could see here there are 10 songs and the item look like that way. It means that for each song this is the information we are going to get. Now if you would want to create a list of certain values such as item, artist, song name, release, popularity, so these are the fields we are interested into. So this is how you are going to parse the data. So this data will be used here to parse this information, so we can store all the data into this track result array. So now our track result array has the collection of these 10 top songs related with Led Zeppelin, as you could see here, which year they released and their popularity. Now we are converting this array into a pandas data frame. So here we have our pandas data frame, popularity and release date. And now for each song we are going to get the audio features, which we have done in one of the previous exercise. So I will fast forward this little. So now we have features data frame and here we have the track data frame. So next step is that we have to merge these two data frame together because we do have ID field in both of the data frames. So this data frame has the ID and this data frame has the ID. Here is the ID field. So the merge is going to happen. This is our final data frame. And now we are going to sort this data frame on popularity. Next step is to just select a particular audio feature and create this subset of our data frame. So here we have popularity and tempo. And next we are building the graph. So for Led Zeppelin top songs, here are the tempo seen in those songs and the comparison of these bubbles along with the popularity. If you want to make a graph better, so we do have the Altair library which you could use. Make sure that Altair is installed in your machine. If it is available in your machine, you can import the Altair, and here you are creating the bubble chart. So here you could see that popularity is on x-axis, tempo is on y-axis, and here the popularity is also based on color. So you could understand which song is less popular, which song is high popular, and wherein it exists in popularity versus tempo. If you would want to change this property to something else, you could just select one of the property. Let's use the danceability. Is a rock, so kind of little tricky, but let's see. Here you go. That's how this result came up. And if we will try to build here, here is your popularity and danceability. Here you could see that graph is visible and popularity, danceability, song, album. So these Altair graphs are little more clear, much more better in terms of representation. Here in Matplotlib, you have to customize a lot to get it done. So these are the pre-customized graphs. So that was another example we had in this tutorial. So let's very quickly, we can review what we have completed. So very first, we learn how to use the Spotify APIs to get the audio tracks, search for audio tracks, or search for albums, or search for songs, or search for artists, depending on what our needs are. And after that, we have collected the songs and you extracted the audio features for individual song. And once we have these features, we build this polar plot to understand the different values related with the given audio features and also compared for 2 or more songs depending on our requirement. In this second exercise, we used the pre-built Spotify API to get the song recommendation, and we understood the recommendation comparison based on popularity. Next, we use the audio features comparison for multiple songs in variety of ways. And in number 4 workbook, we use the Spotify APIs to get the top songs related with a particular artist, and once we received the JSON result, it also had the audio preview for a 30-second, not for every song, but for certain songs. So if the preview is available, we also play it. And finally, in the 5th one, where we use the top songs for a given artist, and we compare the song comparison with the popularity all together into a more visualized manner, so we could understand the results much better. And we also use the Altair graphs for a little more clarity in our comparison visualization. So in this tutorial, you have seen how we have used the Spotify APIs to collect various details about the artist, songs, playlist, tracks, top tracks related with an artist, and we visualize all that information. But there were some limitation with Jupyter Notebook. We could do some data analysis. However, we could not build a better application if you would want to have the smooth switch between the popularity versus audio features, or we want to have an application where we could search as many as songs or artists and their top songs if we want to search. It would be best if we could have compact all that information what we have completed in this exercise through Jupyter Notebook, and we build it into an application. Means, and if we could convert this whole exercise into an application where we could search for songs, artists, we could also search the top songs related with a particular artist, or we could search songs by the keyword, and the information what we get, very quickly we can make a call to get the audio features related with our targeted song. We can look into their popularity, we can search everything all together very quick. So that would be our objective for the part 2 of this presentation, where we are going to take all of this Python code which we have used in this tutorial and convert it into a Python application. So we are going to use the Streamlit open source library to build an application where we could perform everything which we have completed in this tutorial. So please stay tuned for the next tutorial, and that will be a new video where we are going to build the Streamlit application, and we are going to use almost everything what we have done in this Jupyter Notebook. Until then, thank you so much for your time, and I'm looking forward to see you in my next video. Thank you.
That's all, my friends. If you have enjoyed our content, please like it, share it, subscribe it. And finally, please remember, be good and do good. Thank you.